In today's video, you will learn what an arc length is and how to determine its measure. If your lesson is on circles and you are on determining the measure of the arc length, or if you have an assignment on this topic, or if you are preparing for a test in math, or a test in geometry in particular, then this video is for you. Let us start by describing an arc in a circle. An arc in a circle is an unbroken piece of a circle with endpoints on the circle. The part of the circle from A to B is called arc AB with this symbol. The arc subtends an angle to the center of the circle, which is the central angle. We will use the symbol theta for the central angle. An arc length, or length of the arc, is how long that arc is. Hence, its unit of measures are length units like inches, meter, feet, etc. Circumference, as everybody knows, is the total length around the circle. This total length has the formula of 2 pi r, where r is the radius of the circle. As you see in the drawing, the arc length is just part of the whole length of the circle, which is the circumference. Likewise, the angle subtended by the arc, the central angle theta, is also just a part of the total angle around the circle, which is 360 degrees. These part-to-whole relations are equivalent, thus a proportion can be written as follows. Arc length over the circumference is equal to the central angle over the total angle in a circle. Plugging in the values that we know of, such as the circumference and the total angle in a circle, we have now arc length over 2 pi r is equal to theta over 360 degrees. This is where our formula for the arc length comes from. Multiplying both sides of the equation by 2 pi r gives us the formula in finding the arc length. Thus, arc length is equal to theta over 360 times 2 pi r, where theta is the central angle in degrees and r is the radius of the circle. Take note, you must have these values of the two variables, the central angle and the radius r, in order to solve for the arc length using the formula. Now, where are these variables, theta and r, in our circles? Oh, they're here. There you are, learners. That was quite long, but at least you know now where the formula is from. Okay, let us use the formula in solving some problems. Here's the first problem. Calculate the length of the arc cut off by a central angle of 50 degrees in a circle with radius of 7 inches. Can you visualize the situation after reading the problem? A good practice is to represent the situation through drawing if there is no figure given. Let us try to draw a figure representing the situation. We have a circle with a central angle of 50 degrees and a radius of 7 inches. There you are. We now have the figure. Let us look now at the problem again. What are we looking for here? Okay, since the problem calls for the arc length, the next step is to have the formula for the arc length. With the formula, we now ask ourselves, do we know the central angle theta and the radius r? The central angle and the radius are given in the problem, so we just plug in those values. Putting all the numerators together, we have. At this point, we can simplify the value using a calculator. When simplifying the value using a calculator, try to input pi instead of using the value of pi, which is 3.14. Using pi will give you a more accurate answer. But if you are instructed to use 3.14, then go ahead and just use 3.14. Let us use pi in determining the answer in this problem. Okay, in this type of calculator, the TI-84 calculator, you must hit the second key first, then pi, to be able to input pi. Multiplying the numbers in the numerator gives us 2,199. Dividing 2,199 by 360 gives us 6.1. So, the arc length is 6.1 inches. There you are, we have an answer. The length of the arc cut off by a central angle of 50 degrees in a circle with a radius of 7 inches is 6.1 inches. Did you get it? Let us try another problem. Here is the second problem. The circle with center O is divided into sectors. In circle O, segment VS is a diameter. The radius of circle O is 6 units. We are given a figure here. Find the exact value of the length of the arc corresponding to the subtended central angle, angle VOU. Okay, so the problem has a given drawing, so analysis will be easier. All we need to do is to look for the given information in the drawing. To begin, we must read the problem and read it several times when needed to know what we are looking for, what are given, and how this given information will be able to help solve what we are looking for. Let's start by knowing what we're looking for. We are looking for the exact value of the length of the arc corresponding to the subtended central angle, angle VOU. Where is this in the drawing? Let us first look for the arc in the drawing. This arc subtends the central angle, angle VOU. Okay, so this is the arc, and its length is what we're looking for. For us to answer this question, we need to know the measure of the central angle theta and the radius r of the circle. These requirements are seen in the arc length formula. Let us start by determining the measure of the central angle theta subtended by the arc UV. In the problem, it is given that segment VS is a diameter of the circle. We know that the diameter cuts the circle into half. So, if the angle around the circle is 360 degrees, then half of it is 180 degrees, right? The two sectors on the lower half of the circle have central angles of 45 degrees and 25 degrees. Adding these two gives a measure of 70 degrees. So, what is the measure of angle VOU if half of the circle is 180 degrees and the two other sectors on the lower half of the circle have measure of 70 degrees? There you are. To get the value, subtract 70 from 180 degrees. This gives you 110 degrees. This is the measure of the central angle theta that we are going to put into our formula. The other value we need to solve the problem is the radius r of the circle. And this is given in the problem. This is 6 units. Now, we can use our formula. Oh wait, we also need to know what exact value means because we are to answer this in exact value. In math, exact value means no rounding of numbers. So if pi is a part of the number, leave it as is. Do not round it off to 3.14. If there's a fraction in the simplest form, leave that one as is as well. When a value is rounded off, what we get is just an approximate value. These are the numbers written in decimal form. The answer to our first problem, which is 6.1, is an approximate answer. Now, we are ready to use the formula. Plugging in the values for the central angle that we got, which is 110 degrees, and the radius that is given, which is 6 inches, we now have this. Putting all the numerators together gives us, separating the numerical value from pi, we have this now. Multiplying the numerators, we now have this. Dividing the numerator by the denominator gives us 3.666 pi. Now we have a number in decimal form. Remember that we are to write the answer in exact form. We are not to round the number. To change this to the desired exact value, we will use a calculator. We will leave the pi for now and just deal with the numerical part first. This is what we have in the calculator now, 3.6666. To change this to the desired exact value, we must hit the math key in the calculator. This is what we see in the calculator now upon hitting the math key. We hit the enter key this time. This is what we see on our calculator screen. Hitting the enter key one more time, this is the result. Now we have the exact value in fraction form. This fraction in its simplest form is what we want. The decimal number 3.6666 is 11 over 3 in fraction form. We just attach the pi to complete the answer. The exact answer is therefore 11 over 3 pi. So, the length of the arc corresponding to the subtended central angle VOU, is 11 over 3 pi units. We are done and we have solved the problem. There you are, learners. Let us summarize what we have learned on this video. We have learned that, first, an arc in a circle is an unbroken piece of a circle with endpoints on the circle. Second, an arc length, or length of the arc, is a portion of the circumference of the circle that subtends a central angle with length units like inches, meter, feet, etc. The formula to be used in solving for the arc length, if the central angle in degrees and the radius are given, is arc length is equal to theta over 360 degrees times 2 pi r, where theta is the central angle in degrees and r is the radius of the circle. Fourth, an answer could be written in different forms. It could be in decimal form, which is an approximate value, or in terms of exact value. When asked to write the answer in exact value, no rounding of the numbers must happen. Instead, leave the answer in terms of pi or fraction in its simplest form. Fifth, when solving a problem, you must read it and may read it several times to know what you are looking for, what information are given, and to figure out how this information will help solve the problem. Sixth, sketch a representation of the situation when no figure is given. This will help you in analyzing the problem. Number 7, the last one, if a figure is given, make use of it. It is there to help you analyze and solve the problem. Okay, hope this video helps. That's it for now. If you have any question, leave a comment below and do not forget to like, subscribe, and share this video to your peers so others will learn too. Bye.